Today I'll explain how to properly answer the most common questions in a React interview. The most frequent question that usually starts any React developer interview is, tell me, which hooks do you know? Of course you can just blur out all the names you know, but it's much better if you also briefly explain what each one is used for. So, the main hooks that you can and should mention are useState, used to store and change component state, useEffect, for performing so-called side effects of a component update, for example API requests. A side effect is anything that interacts with the outside world from within the component, like subscribing to external events or fetching external data. useRef, used to store a value between component updates. Unlike useState, changing this value doesn't cause a render. It's also used to hold references to DOM elements within the component. useContext, for accessing values from a React context provider node. useCallback, for memoizing functions to avoid unnecessary renders in components that receive them through props. And useMemo for storing results of expensive computations so they don't run on every render without a need. You could also mention useReducer, an alternative to useState, allowing you to use a reducer function to manage state. It's usually used when the state is an object with many fields, not just a primitive like in useState. And useLayoutEffect. It's similar to useEffect, but it runs before the browser paints the screen. It's used when you need to calculate or modify something in the DOM tree and want to avoid visual flickering for the user. Let me put it straight. Don't start naming hooks from custom React libraries you once used. The interviewer might not be aware of them, and your attempt to show off might not land as intended. I give you my advice. Keep your answer to this first question short and simple, and stick to standard React. Let's move on. In React interviews, questions about the specifics of using the useEffect hook are very popular. This is mainly because this particular hook plays a major role in the most serious mistakes developers make when working with React. Within a project, the use of useEffect is the most dangerous area, and an inexperienced React developer can cause a lot of trouble if they don't understand how it works. After switching to functional components, this single hook replaced 3 key lifecycle methods of class components, and the difference is in which parameters you pass to it. They might give you a code snippet like this and ask to explain the difference in behavior between the different useEffect calls. In the first case, the function passed to useEffect will run on every render. This is somewhat similar to component updating class components, and it happens because we didn't pass anything as dependencies array. In the second case, the function will run only once on mount. As you probably guessed, this is equivalent to component.mount. Take a notice that we pass an empty array as dependencies. In the third case, the function will run whenever the value specified in dependencies array changes. But now you might ask, wait a minute, you said that this one hook replaced 3 lifecycle methods, but you mentioned only 2. That's right. The function you pass to useEffect can return another function, so-called cleanup function. React will call this cleanup function before the component unmounts, or before rerunning the useEffect if its dependencies have changed. Here is what the cleanup function looks like, and this is essentially the equivalent of the component will unmount method in class components. One of the most common mistakes in React related to useEffect is forgetting the cleanup function when subscribing to DOM events. In this case, your component will resubscribe on every render, which leads to memory leaks and most likely a performance drop after your app runs for a while. The most important theoretical question in React interview is about its lifecycle. This is the very foundation of React, and if you don't understand it, then unfortunately your interview will come to an expected end. They'll promise you to call you back, but never will. So, there are 3 main phases in a component's lifecycle. Mounting, when the component is added to the DOM tree, updating, when the component's props or state change, and unmounting, when the component is removed from the DOM tree. All these phases can be tracked and changed with custom logic, either with the useEffect hook and functional components, or in case of class components with built-in lifecycle methods. Even though class components are barely used anymore, you might still be asked about their lifecycle methods corresponding to these phases. And these are component.mount, when the component is added to the DOM tree, component.update, when the component updates the DOM tree, and component will unmount, called right before the component is removed from the DOM tree. And most likely, right after this, you'll be asked how to manage these lifecycle phases in functional components. To answer that, just remember what I recently told you about how useEffect works in different scenarios. In React interviews, they also love to ask about buzzwords like virtual DOM, reconciliation, immutable state, and per function. So what are these? Let's start with the virtual DOM. That's when you took a mortgage at 10% interest, but the house was never built. But in reality, this is a lightweight copy of the actual DOM that exists only in memory. React compares this virtual DOM to the previous version using diffing. And yes, that's another buzzword. Diffing means comparing different versions of the DOM on each update. If it finds any changes, React updates only the parts that actually changed. This whole process is called reconciliation, the process of finding differences and updating the real DOM tree. The virtual DOM is the killing feature that made React so fast comparing to its main competitors, Angular and Vue. Even a fool can understand that comparing things in memory is way faster than manipulating the actual DOM tree. Next, immutable state. Literally, it means unchangeable state, but in practice it refers to the principle where the state object is not modified directly. Instead, a new copy is created with the necessary changes. Why is this so important? React, when checking for changes, compares values using strict equality, meaning it checks whether the reference to the state object has changed. This is the fastest and the most efficient way, as it avoids digging into the object and comparing each individual field. If the reference has changed, great. That means the whole component should re-render. What's inside will be managed by child components that are subscribed to specific fields from that object. And finally, a pure function is a function that always returns the same result for the same input. It also has no side effects, meaning it doesn't modify external variables and doesn't make API requests. Remember what I said about useEffect, that hook is specifically designed to handle these side effects inside functional components. In React, it's best to keep your components pure. That way they're easier to test and their rendering becomes more predictable. Following this principle, you should never mutate the fields of external objects that come through props. If you need to modify them, make a copy first, and then change the copy. This is an example of a very impure component that messes up your data every time it renders. And this is how you can make it pure. In interviews, they often ask about React ANSI pattern called prop drilling. It's a very basic mistake in component design and architecture, yet many spaghetti coders use it all the time in practice. So, property drilling is when you pass props through several intermediate components that don't use them on their own, but just pass them further down the tree. Here's an example. We can see that the user object is passed from the app component to the child component through the parent component, which doesn't use it at all. Maybe in this case it's not a big deal, but prop drilling can go through 3 or even more components. First of all, it forces you to add props to components that don't actually use them, which makes the code harder to maintain and turns it into spaghetti. So, how do you deal with this? In classic React it is solved using context. I've already mentioned the useContext hook, and this is exactly what it's used for. You'll just need to place a context provider somewhere higher up in the component tree so that it becomes available to all child components. It will look something like this. At the first glance, it might seem like there is more code now, but in reality, we have eliminated necessary props in parent, and now child can be placed anywhere deeper in the component tree, even wrapped in other components. If it's not so obvious now, you'll definitely feel it when your app grows to hundreds or even thousands of nested components. What is strict mode in React? Many people have heard of it, and for many it's enabled by default, but only a few truly understand what it actually does. Strict mode is a development tool that helps identify potential problems in your application. It's very easy to enable. You just wrap your entire component tree in a React strict mode node, like this. So, how does it work? First of all, during rendering, it calls all lifecycle functions twice. This helps detect and save code that might produce memory leaks. This way, it can identify and warn you about incorrect hook usage and unsafe side effects. It also gives warnings about the use of deprecated APIs. Note that this mode only works in development. In the production build, it has no effect. Here's a typical example of unsafe side effect. In this case, you'll probably get a warning like "Can't perform a React state update on unmounted component." React detected this because you didn't implement cleanup logic in your useEffect, which would have cancelled the request when the component unmounted. Now, imagine this situation. You've been successfully developing React apps for many years, always using the built-in hooks like useState, useEffect, useRef, and maybe a few hooks from external libraries you commonly use with React. And now you're interviewed for your dream job as a React developer, and suddenly they ask you to write a custom hook, the simplest one, but you've never done it before. So what do? Fail the interview? Because if you don't even know how to write your own hook, that smells like a failed interview. That's why you must know how to write custom hooks. It's a very common interview question. But here's the good news, it's not hard at all. You can think of a custom hook as simply extracting started hooks in a separate function whose name starts with use. For example, here is what a custom hook to get the browser window width might look like. Inside, you'll see the familiar useState and useEffect, we're just wrapping them in a reusable function. Why do we do this? For the same reason we split the React app into components, to reuse logic across components and avoid code duplication. What kind of logic is usually moved to custom hooks? In addition to things like subscriptions to common events, developers often move logic related to form handling and API requests. For example, fetching data from a server, done the same familiar way using useState and useEffect. Take a note that in this case there is also a check to make sure the component is still mounted by the time the data is received. Remember the rule, it's not recommended to update state on unmounted components, as this can lead to memory leak. In interviews they often ask what React Lazy and React Suspense are, and if you only worked on small projects and never split your app into modules, you might simply not know what they mean. Or maybe you read about them once, but they never stick because you never got a chance to use them in practice. But in large-scale applications these two features are used almost everywhere, except in rare cases where the tech lead does no shit what he's doing, or the project has no requirements related to core Web Vitals performance metrics. Here is a simple example. Let's say we want to dynamically load a component located in lazyComponent.js, and for that we use the React Lazy in the main app. Suspense here is used to display a loading message. It detects if there is a component inside that returns a promise, like one from React Lazy, and will show the fallback until the promise resolves. That being said, questions about React Lazy can be phrased in different ways, because it's often the correct answer they're looking for. For example, how do you dynamically load React components? Or even, what are microfrontends? The first one is quite straightforward. You can simply mention React Lazy along with Suspense as its wrapper. But the second one is more complex and deserves a more detailed answer. Microfrontends is an architectural design pattern where a large frontend application is split into independent modules. This approach allows development to be split across different teams, each working on their own module, and importantly, each module can be also deployed independently. You don't even have to build the entire app with React. You could combine React with Vue modules in the simple app if you're that crazy. But if your app is built entirely in React, then React Lazy is the tool of choice you can use to dynamically load modules into the main application. A classic React interview question is, what is Redux and how does it work? Yes, now we'll talk about state managers in React. Even a junior developer is expected to know and use at least one. And you'll probably feel the need for one yourself as soon as your app grows beyond just a few pages. You'll want to store data in a more organized place and manage it more conveniently. But why do they ask about Redux so frequently? It's already outdated and almost no one is using it. Except maybe for some devs who got stuck in the past decade and not growing since then. Indeed, there are a ton of alternatives that are far more convenient, and even wrappers on top of Redux that reduce the amount of boilerplate code you need to write by a lot. So really, Redux is a more theoretical interview question these days, but it's still relevant because many of its core concepts overlap with React itself, like pure functions, mutable state which I already talked about, and even the mechanics of the built-in user-reducer hook, which is a part of vanilla React. So, even though Redux is rarely used today, except in legacy projects, it's still a good idea to understand how it works, so you can explain these shared concepts like a champion. Here is a scheme of classic Redux. We have three key components in the Redux architecture: the store where the data is kept and where the so-called reducer is located, the view or UI which subscribes to this store and receives the state from it, and the dispatcher. Is triggered by the view in response to user input and sends actions which then mutate our store. The reducer processes these actions and creates a new copy of the state with the updated fields. So, why Redux is so inconvenient and you shouldn't use it under any circumstances? The thing is, you have to manually write each part of this setup, create new actions for every change to a field in the state object, and sometimes there are even multiple actions for a single field, like increment and decrement. But that's not all. You also have to write the handlers for all these actions in the reducer itself. All Redux does is manages the data flow between these components and provides methods to subscribe to the store and dispatch new actions from the UI. This is exactly why people hate it so much. For every new field in the store, you'll have to write dozens of lines of code just to change it. The only advantage it has, it works well for event-driven development, where the system state is fully controlled by formalized business events. And it's somewhat more convenient for time travel. But its downsides definitely outweigh its benefits by far. If you can provide some good arguments to explain why it sucks and what better alternatives exist, you'll get some bonus points in the interview. Component libraries. Yes, they're also frequently asked about in React interviews. An experienced React developer will never write every component by hand, because there are tons of free and convenient alternatives out there. The question have you used any component libraries is actually a good sanity check. If you say no, it immediately shows that your experience is very limited and that you've never built anything more complex than simple forms or tiny apps. Or even worse, that you spent your entire developer life reinventing the wheel, which is a massive red flag and a good reason to stop the interview. So you should definitely try at least one component library, and not just to answer interview questions. You'll feel its value when you need to build something like a full-featured dashboard for a service. But most importantly, you'll learn the standard names of UI components like accordion, card, skeleton, breadcrumbs, toolbar, drawer, tree view, and others. You'll also become more proficient in UI design. You'll learn how layouts are built, how to group and present large amounts of data efficiently, what input components exist beyond basic HTML tags, how typography and icons work, and how to implement theme switching in your app. All of this is very useful and interesting, and using a component library gives you a chance to see how it's done in a proper, maintainable app made by a healthy human, not by some crackhead. It naturally builds your sense of structure and good practices, even if you later decide to write components manually. So, which one you choose? Honestly, just go with the one you find most attractive. They all have storybooks where you can scroll and click through components. Maybe the one you'll like its icons more, or maybe another has some useful components you'll really need. I would recommend choosing from these three most popular ones: Material UI, ND, and Bootstrap. The first two are more modern, and Bootstrap is simpler. Check them out, pick one, and if you don't like it much, build your next project using a different one. In any case, this will give you lots of practical experience working with third-party components, and that is extremely valuable. Server components. For many React developers, this question can come as a surprise, and unfortunately become a deadly one for you. The thing is, Create React app was only recently officially deprecated, and there are still a lot of developers out there who continue to write classic single-page applications without any support for server-side rendering. If the client doesn't need it, why bother? That's what they think. Until the moment they show up for an interview at a company that does build websites with SSR support. And obviously, if they get to choose out of two candidates, they'll pick the one with SSR experience. Quite frankly, beginners might not have this issue at all, simply because they got into React development after Create React was retired. And the recommended stack for learning React became Next.js, which supports SSR out of the box. So if you started with Next.js, you'll find it easier to understand. But either way, it's important to know what server components are and what their features and limitations are. So, what are server components? The key difference from the regular components is that they run only on the server. Their code never reaches the client, and they can access databases and external APIs directly, but they cannot use client-side hooks like useEffect and useState. These components are used to enable SEO or search engine optimization, basically to make your site indexable by search engines. As you can see, in this component we're making an API call directly using await fetch, something we usually do inside a classic React component using the useEffect hook, and then update the component state using setState. You might find this form much more convenient, but on the other hand, the page won't load for the client until the API request is complete. So, if time to first contentful paint is a priority, it's better to let the client see a skeleton first, and then display the actual data once the request finishes. So, today we went over the 10 most common questions asked in React interviews. And that's all for today. Like and subscribe if you want to see more videos like this.